Welcome back, Matlos. Today I got a answer, to be honest, for a very prolonged question in mathematics. Like, where is the real life application? Why are you asking me to memorize all these formulas? Why do I need to do that? So, one of the most uh, beautiful answer for that question will be optimization. In our life, we are always, interested to optimize things like reduce wastage, reduce losses, increase profits, increase concentration, increase effectiveness. This has been our life's goal almost. That will always help us improve. Many businesses or many operations, companies all work on this only, optimizing, which is basically the effect of mathematics, or I would say calculus, effect of calculus. So just imagine, I'm just doing a bookshelf. I'm doing a bookshelf for my kid. Which has a depth of d, length of x, and breadth of y. Okay, it's like it'd be a two-way bookshelf. Like two racks are there. Now, if suppose I'm giving this work to a carpenter, like carpenter would try to minimize the surface area so that he'll be able to make the best out of the materials that he has. And he can save some materials, his costing, his profits become more. So volume, we know this is a cuboid. So x into y into d will become the volume of this book rack. But for a carpenter, what he sees is like surface area only because he wants to minimize the surface being utilized. So surface area, if I write surface area of this object, if you notice, the bottom is a rectangle x into y, top is also a rectangle x into y. Okay, so I think I marked y in the wrong place. So what I'll do is I'll put y here. Okay, this is d, right? So the bottom rectangle is x into d, top rectangle will be x into d. This middle one will also be x into d. So altogether there are 3xd. Okay, and now coming to the back surface, it will be x into y. Okay, and the side rectangles, it will be like d into y, so 2 dy. Now altogether in this area we can see there are three variables being utilized. X is there, y is there, d is there. If we wish, we can reduce it to two variables with the help of volume, because like say I want the volume to be in to be the same, like without reducing it. So what I can do, I can particularly try and remove this d variable as such, because volume is fixed. As a output, I don't want the volume to change. Say volume is going to be fixed. The space for storage of the books, that be fixed. So in the place of d, I can be writing it as xd. I can write it as 3 times v by y. Okay. And in the place of xy is there. So that's okay because it's like single variable to me, which is basically v by d. But I don't want more than two variables to be there. Next comes dy. So which can be written as 2v by x. Now, for the carpenter, since he knows the volume is fixed, he is bothered only about two variables, which is x and y. So you would try to alter them only with respect to x and y. So that's where the idea of partially checking the impact of variables comes. That's called partial derivative. We check the impact of the area with respect to variable x, with respect to variable y. For that, we use a symbol called dou. If you want to check the impact of area with respect to variable x, that means x will be the variable, y will be considered constant. So in that case, v is also fixed for us, y is also constant for us. So differentiation of a constant will be 0. This term will go. Okay, and x is my variable, y is just a constant as such. So y into 1 will be the differentiation. And 2v by x. if you see like again v is constant, 2v is constant, so 1 by x differentiation we'll get like minus 1 by x square. So we will be able to achieve this minimization like when we equate the derivative to 0 generally. So similarly we can check the partially effect of the area with respect to the variable y. So hence again this 2v by x will be considered as a constant then with respect, because I'm doing with respect to variable y. So then this will become 0, and here y is a variable, x is a kind of a constant, so x into 1. And here 3v by y, so 3 will be as it is, 1 by y differentiation will be minus 1 by y square. We can equate this to 0. By solving these two equations, we'll be able to achieve the dimension this carpenter would require. Okay, so this gives us y equal to 2v by x square, and this gives us 3v by y square equal to x. Okay, hope you understand. So now in between both of them, what is common is v is common. We can utilize that idea. So x square y by 2 is equal to v from the first equation. From the second equation, I'm getting v equal to xy square by 3. Okay. So now if we compare both x square y by 2 to xy square by 3, I can understand x getting cancelled, y getting cancelled. I'm left out with x by 2 equal to y by 3. Okay. X by 2 is to y by 3. So that is basically, if I take as a ratio part, we'll understand if I'm going to compare them to a number k, x equal to 2k, y equal to 3k. So the ratio in which you should be taking them, that is the x is to y, so it should be 2 is to 3. The length is to breadth, here the breadth of this cupboard or this book rack should be 2 is to 3 to make minimize the surface area possible for the carpenter. So hope you like this idea, or the understanding of calculus began all of our lives, and which is still improving our lives. So we'll meet you in a very interesting video later.